Welcome to the first lesson in relationships on interpreting graphs. By the end of this lesson, you will be able to determine if a relationship exists between two variables and if that relationship is increasing or decreasing. Before we get into the math and graphing, I have 3 pictures here, and in each set of pictures, I want you just to think about the relationship that could possibly exist. So in the first one, there is a picture of 2 hands. One is smaller and one is bigger. What do you think the relationship is between the height and the hand span of a person? In picture B, we see 3 seasons: spring, winter, summer. And what do you think the relationship would be between the temperature and the sale of gloves? And then in part C, we see 2 men, a short one and a tall one. And I want you to think about what is the relationship between height and salary. So pause the video now and think about those 3 relationships. In the first picture, usually when someone's hand is bigger, it means they're taller. So as the hand span increases, the height increases. And we will start talking about this as an increasing relationship. In B, the sale of gloves would happen more in the winter. So as temperature falls or decreases, the sale of gloves increases. This is called a decreasing relationship because the temperature is going down or decreasing, but the sale of gloves is going up. So they're going in opposite directions. And finally, in C, height does not affect your salary. So there's no relationship between height and salary. So those are the 3 types of relationships: increasing, decreasing, or no relationship. So let's look at these relationships in graphs. So when you are given bivariate data, which means data for 2 variables, we often plot them on scatter plots. So it's a graph with points on it, which shows the relationship between the 2 different variables. And it allows us to see those relationships. So we're going to look at some examples where the graphs are drawn for us. In the first one, I have age and I have number of siblings. So age is my first variable, and the number of siblings they have is my second variable. So I've gathered some information. I've asked somebody, they said that they are age 15 and they have 1 sibling. The next person is also 15, but they have 6 siblings. The next person is 14 and they have 8 siblings, and so on. And then I went and graphed all of that data. So I have a scale at the bottom, and here's my first. Someone who's 15 who has 1 sibling. Here's someone who's 15 and has 6 siblings, and so on. I even have someone who is 20 years old and they have 15 siblings. This point here is very interesting. Not many people have 15 siblings, so I would call this an outlier. It's different from the rest of the information. Now, before I started talking about these points, I should have labeled my axes. So you should know that my x-axis is along the horizontal. It's also known as the horizontal axis, which is this one right here at the bottom. So my pointer's not working. This one is my x-axis. So that's where age is. And along my y-axis, which is my vertical axis, I should write the label number of siblings. The scale is done for us, but we are asked, what is the vertical scale jumping up by? So the vertical scale is on the y-axis, and I can see it goes from 0 to 5. So what does each little line represent? Each little line of the grid. So I can see there's 1, 2, 3, 4, 5 lines up to 5, so each one is worth 1. That was pretty easy. My Horizontal scale is not so easy because I have 1, 2, 3, 4 lines to get to 10. So what I'm going to do now is just see what would half be. So 2 lines over would be 5. And so then half of that, which is 1 line over, is 2.5. So each point, or each line in the grid is worth 2.5. Is there a relationship between age and the number of siblings? I did not see a pattern on this grid or on this graph, so I'm going to say no. And how can you tell? You can say there is no trends in the data. So there is no trends. And because there's no trends, visible trends, I can say that there's no relationship. There might be, but I would need to collect more data. In the second example, we are given age and the number of years until retirement. So age, again, goes on my x-axis, my horizontal axis, and the number of years until retirement goes on my y-axis, which is my vertical axis. Okay, I squiggled it in there, but you should write it out properly. And then each of these points are plotted. So at age 15, you're 50 years away from retirement. At age 14, you're 51 years. And we can see that once I plot all the points, there's a pretty visible trend. Okay, so the questions. What is the vertical scale jumping up by? So let's look. It's not going up in ones, and it's not going up in tens, but if you count 5, 10, 15, 20, so it's going up in fives. And age along the bottom, 5, 10, 15, 20, it's the same thing. So is there a relationship? We said yes. How can you tell? There is a trend or a pattern. In the lines, there's a pattern in the lines. Describe the relationship. I'm going to say that it is decreasing. As age increases, the number of years to retirement decreases. And because there is a relationship, we are asked if it's linear or nonlinear. It forms a line, so it is linear. In example 3, we have age, and we have the number of years you are older than a 7-year-old. So someone who's 14 is 7 years older than a 7-year-old. Someone who is 20 is 13 years older than a 7-year-old. So we'll plot age along the x-axis and number of years older than a 7-year-old is on my y-axis. The points are plotted for us. And we see again that they form pretty much a line. We are asked again, what is the vertical scale jumping up by? So let's try 0, 1, 2, 3, 4. Nope. 0, 2, 4, 6, 8. No. So this isn't very as nice as it could be. So let's cut it in half to get 5, and then we cut it in half to get 2.5. So it's going up in 2.5, and the horizontal axis is the same. So is there a relationship? Yes. How can you tell? We can say there is a trend in the points, or pattern in the points. Describe the relationship. It is an increasing relationship. As the age increases, the number of years older than a 7-year-old increases, and it forms a line, so it is linear. And in example 4, we are given time and the height of a ball in meters. So a ball is thrown, usually a ball is thrown in the air and then it lands back on the ground. So here the x-axis is time, and in brackets I'm going to put S, which is the units, and on the y-axis it's height, and in brackets M for the units. So all the points are plotted. We're asked what is the vertical scale jumping up by? It's easy. 1, 2, 3, 4, 5. And same with the horizontal. 1, 2, 3, 4, 5. So they're both going up by ones. Is there a relationship between the age and the number of... No, so this is wrong. So is there a relationship between height and time? And this relationship is a little bit different. There is one that exists because you can clearly see the path of the ball and you can predict the ball at any time, the height of the ball at any time. So we can say yes. How can you tell? There is a trend. So a trend exists, so you can say there is a trend. Describe the relationship. Well, it goes up, so it's increasing. So it increases, and then it comes down, so then it decreases. So there is a relationship, it's just non-linear like the other relationships were. The points didn't form a line. So this is a non-linear relationship. Okay, so let's just do 3 examples to describe some relationships. In the first one, we want to describe the relationship of the hours someone studies for an exam and their final grade. So if you think about it, if the hours that someone studies increases, their final grade should also increase. So we expect that to have an increasing relationship. Or you could think of it as if the hours goes down, the final grade would go down. The next one, the temperature and the sale of gloves would have a blank relationship. So if the temperature increases, you would expect the sale of gloves to decrease. So they're going in opposite directions. So you would say it would have a decreasing relationship. You could also think of this as if the temperature goes down, the sale of gloves goes up. And again, they're in opposite directions. And finally, the height of a person and their income would have no relationship.